Alright, I think we're live now. Excuse me. Alright, that should do. Alright, cool. I think that should do, right? Alright, cool. Hold up. Let me edit the title of the stream. There we go. And then let me tweet it out, guys. And then we'll get started. Twitter. Yeah, so welcome to the stream, guys. Hopefully y'all missed me. I know we didn't have a stream last week. I was kind of in New York, but yeah, we're gonna be back with R again. We're gonna see how well he's been doing. He has an upcoming interview with Amazon, and you know he is. I think he's ramping up pretty well. I think that he's been doing pretty well, and so we're gonna see like. If he's ready to go in. I think this week will be very telling. All the work that we've been doing for the past, I want to say like 6-7 weeks. So hopefully with this, we'll be able to get a good idea of if he's going to succeed or not. In the meantime, let's actually look at some Y Combinator news. So the big one is that Jack Dorsey resigned from Twitter. But let's see what he says here. 16 years at the company, co-founder to CEO to chair to exec chair to interim CEO to CEO. Time for him to leave. Why? Importance of company being founder-led. Yes. There's limiting and single point of failure. All right, sure. Making sure that the company can break away from founders and founding. Sure. Why? The question is why does he want to do that? I mean, for instance, Uber went IPO without its founder Travis at the helm. So my question is whether this statement is bullshit or not. So Parag's our CEO. The board ran a process considering all options. He's been my choice given how deeply he understands the company and its needs. Parag has been behind every single decision. Blah 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 blah. Second is Brett Taylor agreeing to become our board chair. All right, who the fuck is Brett Taylor? That's Brett to join our board when I became CEO. He's been excellent in every way. Understand entrepreneurship, blah, 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 blah. He's an engineer on the board. Company. Okay, so Brett. So he's installed someone he has influence on the board. Okay, I think this makes sense from a political angle. All of you, blah, blah, blah. Parag is an engineer. Now he's a CEO, blah, blah, blah. This alone makes me proud. I'm going to serve on the board through my term to help Parag and Bet with the transition. Leave the board. Why not stay and become the chair? Okay, sure. He's freedom of its founders' influence or direction. Okay, this sounds like okay. According to the rumor mill, and don't quote me on this, but basically one of the reasons why Jack got kind of pushed out the door was one, he's the co-founder of both Twitter and Square. And Square has made a very, very hard push to support cryptocurrencies. Now, whether or not Twitter, and one of the things was that Twitter was kind of, quote-unquote, considering investing in crypto as well. So essentially what this meant is that you have influence from Square feeding into Twitter, and Twitter feeding into Square. And in fact, I'm pretty sure if you look at the stock price for Square, the stock price would be somewhat fairly correlated based on the news today. So you do see, like, for instance, Square here does take kind of a shit, opening 220 and then shits the bed, even though like this reads 0.37. But then if you look at like Twitter stock price, it's down a whole lot more. Like, but you can see here, like, basically the opening to trend is actually pretty much the same here. OpenAI just takes a ginormous shit here. So it does have some somewhat correlation, just because Jack runs both companies. Either way, I am not, how to say, I don't care that much that he's leaving. I think that Twitter's in a okay space right now as far as what the company is trying to do. I think that for all the things that Twitter's done, there's still plenty of room to innovate, but right now it hasn't really done that. I mean, Twitter Spaces kind of just followed Clubhouse. You know, you have all these new features that at this point, my point here is that every social media company is copying every single other social media company, and so all of them are really just fighting for their slice of the pie. So Twitter expected to go sideways for a very long time. So this move does not bother me at all. In fact, I'd be a little bit long on Twitter because of this. So take that as you will. I think putting engineers at the helm is not a bad idea, but I think more that we're just playing out of ideas for what we want to do for social media companies. Engineering wise, I think Twitter is fantastic, but I don't believe that they are quote unquote the future of what needs to be done. I think it's more or less like everything is now in the hands of a caretaker. I don't think Twitter is going to make a big push for anything substantial in the future. So no big moves. That's at least the way I see it. Alright. What else is here? Music is a super negative stimulus for speech. Observability versus monitoring debate, irreverent review. Okay, this looks pretty interesting. It's by Ubuntu. Okay, except all. In the past few years, words observability has gained traction around in the discussions and monitoring DevOps, blah, blah, blah. Yes. However, there's significant confusion about the overlapping difference between observability and monitoring. So, okay, so this basically is saying what monitoring versus observability, and a vernacular difference between the two. I'll look at the rest of the internet. Alright, so let's actually see what they're saying. So, poking around the Google Trends, you can see there's clear interest around 2019, and the interest is growing, sure. Open source distributed tracing began to take hold in the collective consciousness. Alright, so you kind of take away that open source software does influence shit. Distributed tracing has been the heart of most commercial application performance management tools of 2010, from the developable Interscope to the newer crop of tools. It took open source software to make tracing really popular, yes. Observability is clearly more prominent in North America and a lot of Asia, while monitoring is in the topic of search of Russia and everywhere else. So basically, they're just trying to break down the usage of this by geographic location. Europe is split over it, with Germany and Spain searching predominantly for monitoring, and blah, blah, blah. Okay, Twitter went for the fun answer, and I love it for it, sure. Observability tropes. Observability is put mildly a very loosely defined, yes. Each vendor provides a definition of observability tailored to each one of their current or near future offerings. Nevertheless, there seems to be major aspects in how one defines observability from monitoring, and they qualify mine as tropes. Sure, let's see what he says. Pillar is in context very well understood and widely adopted, such as logs and metrics, so much less so. Distributed tracing, synthetic monitoring, and continuous profiling. Message around monitoring tools tends to focus on particular types of telemetry. Alright. Observability is monitoring plus powerful analytics. Okay. The question is no part due to land grab for observability and all commercial players. So it's just, observability is just loosely defined. As commercial observability tools tend to have more encompassing offerings, in reality there are many types of telemetry, and which ones are needed depends on the particular use case. What there surely isn't is a golden set of tools, sure, just what you need. Kind of telemetry is also very dependent on what your application does, who it uses, and how. Of course, the more telemetry types a tool supports, the more likely it can collect what you need. Yeah. Okay, so this looks like it's just Observability is a very, very large representation of what it's trying to do here. Trope 2, monitoring collects data, and collected data can be analyzed by more powerful tools, sure. It's true that in past few years, the flexibility of analyzing telemetry has been improved by leaps and bounds. Incremental improvements make a sharp cut between monitoring and observability. It's true that it puts it to bluntly, blah, blah, blah. Changes are not technology shifts, just for fanfare. Some influential voices in the observability community go down, and you pretty much need to have a distributed column store in order to have observability. I've worked with column stores in the scope of observability tool, and they made to work great, but I would not go as far as you cannot do it. Okay, this one is going to be an interesting article to read. Why do you need a distributed column store to have observability? I think just more or less saying you need to have a NoSQL database, like, what's it called, Cassandra or something. But I think that's a topic worth deep diving into. Alright. Artificial AI ops. Extension of observability, granting tooling the power to act in automated fashion on the insights. Excuse me. How well in practice depends on how well the observability tooling understands the failure modes and how reliable are the runbooks that are executing it. Sure. It bears to point out just how much understanding that does in sentence. I want to record multiple times saying that more than root cause analysis, observability tooling does root cause fencing. It tells you, okay, approximately. It approximates it, sure. And it's so it's not telling you exactly where it happens. It tells you approximately where it happens. Sure. So the bottom line is that. Wait, did you make me read all this just to say that it's not clearly understood? What? So it seems like there's an increasing consensus that observability is more than just monitoring. Okay. The terms are still very interchangeable. Okay, so you made me read all that just to describe the state of observability and to say, hey, yeah, they're pretty much the same, but no one knows how to differentiate the two? What the fuck? Alright. I think this top comment kind of summarizes this. Observability isn't just a rebrand of monitoring. It's monitoring plus making the most actionable possible via standardization. Sure. Metrics, logs, and traces. Okay. I guess this makes more sense. And if you really want to summarize the article, I think this is a very good way of doing it. I think to me, like, a lot of the points just kind of went over my head. But it's not necessarily that bad either. Okay, it's 7:56. So, yeah. So let's see. Oof. Google workers sue company saying it betrayed the don't be evil. What? Oh, God. No. Oh, okay. I am not interested in this. Bottom line, I think they were just taking matters into their own hands. And just leaking information is part of activism, and then got fired, and then now they're saying don't, and now they're like suing because they got fired. What the fuck did you expect to happen? I don't get it. This actually doesn't. This I don't know. I don't know actually. Let's see who these people are actually. Rebecca Rivers. I think the problem is when you start injecting social activism into how to say software engineering. This actually introduces a lot of issues. I think we've seen this with like the whole episode with Apple II or whatever it's called, where people like are legitimately leaking documents and violating NDAs in order to fulfill their activism, and then are surprised when these companies like say, hey, you guys broke your NDAs, we don't want you here, and then now they're turning around and suing it. It's like surprise fucking Pikachu face. So I don't know, man. I don't know how I feel about this, and honestly I'm more on the side with the companies because it's in their interest to maintain that maintain their bottom line and make sure that their employees aren't breaking the fucking contracts. And on the activist side, they're thinking they're doing good by acting against what the company wants. So they see themselves as whistleblowers, and for the most part, I think that point of view definitely, I would say, blinds them to the realities of how the world operates. Anyway, hey Neon, what's up? Yeah. So if you we're pretty close to time. So I'm a coding interview coach. I work at Uber, and I used to be an Apple engineer. And right now I'm going to be meeting with my client in about 1 minute. He has a few upcoming interviews, and I've been working with him on a long-term basis for both the system design and the code and the data structure and algorithms. So we're going to be looking at hopefully his progress in the past 6-7 weeks, as he leads up to his Amazon interview. So hopefully you guys stick around, and hopefully you guys enjoy this. It's been a long time coming. I think I'm very happy with like the progress I've seen so far, and I'm really hoping he hits it out of the park today, and I can give him my blessing. All right, let's see if he is on. It's almost 8 p.m.
Recording in progress.
All right, let's see what happens. How often do I take with clients? So if you want to book, I have two different services. One is the one-off sessions. You can book those on my website at any time. They're just a 2-hour session that you'll see like that we do here. So what we see on stream today is going to be more or less pretty similar to what you get in that 2-hour session. The other are my long-term clients. And so today's client is a long-term client, and that's only available via application. You have to apply for that, and this is going to not be unlike the coding interview preps courses that you see, except you'll be working with me directly. And there's more info on the website, but bottom line is that the compensation, the way this changes is that I would meet with you more often, and I would take a percentage stake in your results. So that's basically what the difference is. So let me actually link you to the long-term. Let me actually link you to my services page. You can actually find this on my website. Hey, Edbert, do you think a complete focus in backend is good for new grad level engineers? It depends on what you want to focus on. I don't see one way or the other. I think just focusing on the fundamentals of software engineering is going to do you the best good. People start off on front end, then move back end, then become infrastructure engineers. My personal history is I have always been an Android engineer, and I've pretty much stuck with that my entire time. I've never thought like, oh, I'm going to be a backend engineer. I'm going to be a Android engineer again, and vice versa. I think as long as you can think about engineering and coding in the right way, you will succeed no matter what role you're put in. So focus on the fundamentals. That's what I would say. Don't try chasing some random technology stack. Anyway, so let's bring him on. So, hey man, what's up?
Hey man. Yeah. How are you doing?
Hey, I'm doing good. How about yourself?
Just okay. A little tired.
A little tired? From work?
Yeah. From work, and been just trying to do some week code questions just to kind of fill in the gaps the past like 2 or 3 days. But honestly, just kind of stressed. So it was like kind of hard to focus.
Okay. Yeah, you're basically. Yeah. I'm gonna say right now that you're kind of hitting the, I would say the burnout time. I kind of suspected this because this has happened like a lot of times. After like 6-7 weeks, most of my clients start like, oh my god, this all sucks. It's all very heavy, right? And you don't feel like you would rather. You feel like you would rather not study. You'd rather not do anything. So I kind of I knew this is gonna happen. And so today is more or less just we're doing a litmus test. I'm not gonna assign you a lot of work.
Okay.
But for the most part, I just want to see where you're at because I think you're pretty much almost ready.
Okay. Yeah, I think it's just, if anything, it's just more like some gaps that I need to fill in with like certain stuff. Because when I was trying week code questions, I think with the more like generic ones, I think I was okay. But I think the ones that required more like very specific knowledge, for example, one that was more math based, that required me to use like an arithmetic sum formula. Like those were the ones that I like kind of struggle with, but I think like the general ones are like usually okay.
Yeah, focus on the general ones. The ones with the math questions are fucking stupid. I don't recommend that anyone does that. I don't think you should focus too much on that. I think it's just a waste of time. And focusing on the engineering approach is going to always get you 90% of the way there. If they decide to be fussy about the math shit, I think that's a fucking stupid question. So don't worry about that. Anyway, so then let's take a look at like your practice sheet. I didn't get a chance to actually look at that. I see your practice log. Did you link your Google sheet here?
Actually, I think I did link my practice log into the Google Doc we use, but I don't think I pasted much updates to it because I was doing them on LeetCode. So most of my notes were in like the LeetCode questions itself. I don't think I like pasted them into.
Okay.
The...
Yeah. I see that you did some linked list stuff actually.
Yeah.
Okay. And so let me look at some quick reflections that you've written here just to do a spot check. Except they arrived at a solution via some math occurrence equation. Yeah, don't worry. Time complexity. Okay. Yep. Yeah. So you got the same. So I'm looking at this right now. Let me share my screen actually.
Okay.
So you basically got to the same answer that they did, except that you went a little bit more complicated route. And I'm fine with that. I think for the most part, as long as you can get there, you're fine. But I see that 626, 603. Yeah, if it takes you 23 minutes to do a medium problem, I'm actually okay.
Okay.
This is fine. Let's see, relatively easy problem. That's fine. Relatively easy problem. Yeah, so I'm seeing a lot of relatively easy problems here. Good. I think that means that you're pretty much. Yeah, you're doing pretty good. What did you feel was like your hardest one that you did that you really struggled with in the past week or two?
Definitely the math one I talked about. It's on. Do you want to look at that, or do you not? Do you want to talk about a different question?
I want you to the one that you think is that you struggle with because it was the approach that you did sucked, not because the math sucked, but because you felt like you didn't do well in the problem solving.
Okay. So yeah, actually, I can. Yeah, I have this question. I'm not sure if this is considered like math based, but it was. I can. Do you want me to share my screen, or do you want me to just send you the LeetCode link to that
Send me the
question?
LeetCode link and send me the your practice diary if you can. I think
Okay.
I don't see yours for some reason.
Yeah, I'm just pulling up. So the question is a range addition.
Okay.
On LeetCode. Let me.
Range addition 2 or range addition?
Range addition, the medium one.
Okay. Okay.
So yeah, so the question is pretty straightforward. I don't know if you. I'm seeing your screen, but I'm not seeing that you
Yeah,
open
can you
it.
send me the link?
Okay. All right, just send you the link to it.
Okay, I'm waiting for it to come through. And you said you sent it to me?
Yeah, on Discord.
Oh, okay, I see. There we go. All right, let's see what you got here.
Are you? Yeah. Oh, do they need you to have an account to look at a problem?
Yeah. Wait, let me sign in. Subscribe to unlock. God damn it. Fuck. All right.
I can share my screen and just kind of
talk. Let's share
through
your screen. So let's see it.
Okay. Can you enable screen sharing?
Oh yeah, sorry about that.
You're good. All right.
There you go.
All right. Can you see my screen?
Yep.
All right. So this is the question. Let's go to the question first. But basically, it's pretty straightforward. I'm given an array of length,
Okay.
and basically an array of updates that I need to make. And each entry in the element, there's three things.
Okay.
There's going to be a start index, an index, and a update that I have to make. So in this case, it would be applying positive 2 to index 1 to index 3 inclusive. This is kind of what it looks like. Okay. So that's basically the gist of the question, and then you just have to return the array in the end.
Okay.
And like let's see, I think my notes are over. Yeah, somewhere around here. I think like coming to the brute force is pretty straightforward because like it's already laid out to you. You just do the updates one by one. So I would process this first, and I'll process the next, and then the next. And then like I think I was just like very like stuck in terms of like how, like I knew like in order to do this faster, I need to make a constant amount of updates each time. For example, like no matter what the range is, I have to make like either like one or two like a fixed amount of updates. But I guess I just wasn't able to arrive at the solution that that was required in the end.
Okay, wait. Let me guess that the optimal solution is to iterate through every single element in the array, every single position in the array, and then for every single position in the array, you run through all the operations to see if it's within the bounds, and if it's within bounds, you do that addition. Is that right?
No, actually, I thought about something like that too, because I was like, okay, what if I know like what are the bounds of like what is the bounds of the indexes that are going to change, as well as like I also consider like, okay, I'll look through each index and see if this index was ever changed, like different stuff like that.
Yes.
And then the solution is actually a I would say very, very clever, but also very tricky. It's like you have to do I think what they call it's pretty similar to a prefix sum, but in a way you only update the first index and the index after the last index.
Index after the last index.
So in this case, if I were to do this, apply this update, right?
Yes.
I would make this 2, and then I would skip the middle ones, and then apply this one as -2, the 0 as -2.
Ah, okay, yeah, I know. Okay, now I know what you're doing.
And then it would like, yeah, and then it would negate it afterwards. But it's just like I was not able to come up with that. That was like something that, because I was like, okay, I was like even thinking like, okay, is prefix sum gonna help? But like, and typically like the way you do prefix sums just didn't work. I guess like the way they apply it was more like a range sum. But yeah, you would just like update the start index, and then update the n+1 index if it's not at the end of the array.
Okay.
And then from there you do another one pass in the end to kind of apply all the updates all together.
Okay.
But
I know how to explain this to you. Basically, do you remember like a few weeks ago you did a problem that's where you had to remember the difference between elements or something like that?
Yeah.
It's the same thing here. So you follow that same optimization steps, it will be the exact same thing. So let's walk through the train of thought, right?
Yeah.
So we're iterating each time. We're iterating through every single chunk here. For every single chunk, we add a set of numbers to that array, right? To that block of array, right? And then we keep going. So our inefficiency here is that, well, we're doing a bunch of repeated math operations over and over again. And it's like each time it's going to be n. It's going to be n number of elements and then m operations. So it's m by m, right? So what can we do to get it faster is that we need to basically get it down to m or n, or maybe even below that. So the question now is, how do we do that? Well, we could do, even if I did iterate through every single element, every single position in the array, it's still going to put me at m by n. It's just a little bit less because I'm not doing the 2 2 2 5 5 5 3 3 3. I'm only just doing it for each individual position once, but that's still m by n. So then the next question is, okay, well, how do I get even faster than this? Which means that, okay, I cannot I cannot go through each thing that's input that's given to me more than once. So then how do I express that? So if it's all addition, then it has to be the difference. Then that's where the difference comes in. So that's basically how I would have thought of it. I would say that's it's a very clever trick. And like I said before, I think it's worth putting in your toolbox, but I don't think it's something they should sweat over.
Okay. Yeah, I even thought about like, okay, what if I just update the first and the last? Then like I never thought of like updating outside of that range.
Have I ever given you the question of I gave you a server log and your job is to tell me the the maximum bandwidth we need to support?
I don't think you gave me that one.
Okay, that's a question I give pretty frequently, but basically that one is like you're given a bunch of you're given a bunch of requests where it tells you the start and the end of like what they're holding, and what you need to do is tell me the maximum number of connections we need to service. And so the way to do that would be that for every single connection that we have, you do a +1 to represent a connection opening and a -1 in the array to represent the connection closing. And this is just more or less the exact same thing.
Okay.
I know that was a little abstract, but do you understand that?
Yeah, sort of.
Okay.
Basically just using some way of using applying constant amount of updates to kind of record just to make a record in the array in a way that I can interpret later on to give me the answer.
Right. So for instance, if I have like a connection from
Okay.
3 to 6, or let's say from 1 to 3, right? And then my
Yeah.
array is going to be, let's insert a table here. So then I would just, the nice solution is to mark 1, 2, 3 to represent, hey, at these connections that I'm going to have at least one connection, right?
Yeah.
That'd be like the naive way to do it. And then let's say I had like 1, 4, then I would be like, 2, 2, 2, 1, or something like this. I add every single position, right? But of course that's inefficient. So the next best thing would be like, at this position, I add +1, and then I close out the connection at 3 afterwards to represent this. And then here, 1, 4, I do the exact same thing, plus 2, and then minus 1. And that's basically the exact same thing you saw. Maybe it's just a little bit clearer, but it's the exact same trick.
And then how would you in the end how would you so is your question asking for like the amount of maximum amount of connections we need to open in the end?
Correct. Except it's like your problem. Except what they ask is that between 1 and 3 we want to add like say 7, right?
Yeah.
And then between 1 and 4 we add 2. The only difference between your question and what I just proposed is just 1. Instead of having like variable numbers, I just have 1 here. That's it.
Okay.
So, I would say don't sweat too much over this. I think it's something. Again, this is a toolkit that you should have. I think it's a trick worth remembering, but I'd say don't 100% sweat over it. Okay.
Yeah. I think with problems that have like that can be solved through like the typical thinking without having like to think like way too out of the box. I think I feel okay with them, but it's like sometimes when I get questions like these where it requires like some kind of like trick like this, then like I may get stuck.
Mm-hmm. Wait. Okay. So what I want to do today is actually give you one last data structure and algorithm question.
Yeah.
And I think I've given you this question in the past, but I want to give it to you again. And I want to see how far you've come. I'm pretty sure because you have Amazon tomorrow, right?
Yeah.
So our goal today is to make sure that you are prepared, and you're ready for that. So we're going to do one last spot check, and I want to see if there's anything else I can cover here, and then we're going to switch gears to system design.
Okay.
All right. So yeah, I've given you this question in the past, but I think it's a very good question for you to try. So let me start the timer. All right, here we go. So 11:29. So suppose I gave you a block of text and a set of strings. I want you to find me the shortest string in the block of text that contains the set of strings. So, for instance, suppose I gave you 1, 2, 3, 4, 5, right, as a string, and the set was 2 and 4. The longest continuous block that you could give me would be 2, 3, 4, right? And then let's say go to the last question, right? I have this block of text 2, 1, 2, 3, 4, 5, and I gave you the set 2, 4, 5. The longest block of the text that you could give me, or I'd say the shortest string that you could give me is 2, 1, 2, 3, 4, 5. That would contain all of these. Actually, I take that back. It should be 2, 3, 4. Yeah, 2, 3, 4, 5. Actually, yeah. So this is the shortest string. Does that make sense?
A brute force way is obviously like we cannot. Okay. Yeah, it does make sense. All right.
Okay, so
you can hear me, right?
Yes, I can hear you.
Okay. So yeah, looking at this problem, I don't need to care like how many, like this is just a set. I don't have to care like the frequencies of it, right? As long as like my block has like at least one of each of these elements in the set. So with the brute force, we can obviously like kind of compute like all the possible blocks. I guess in this case it would be like substrings, and basically find the shortest substring that contains all elements.
Okay.
Now that's inefficient because we basically like doing a lot of unnecessary computation. I guess like, and then the key is that we only care if the block has like these elements, right? So I guess like another way is that I only start finding elements if I were to see the first one. So what I'm thinking is like, for example, in this case, if I see 2, I would kind of try to find 4. But then that wouldn't, like, I couldn't imagine that working pretty cleanly if we have like a larger set and we have to keep finding. So I'm just thinking of like some way to look at a specific part of the array as we go. Let's see, 2, 4. I'm just gonna write this one down over here. 1, 2. Okay. So we start with 1. We know we don't need it. We go to 2. It's in the set. That's fine. And are we guaranteed that we will have an answer in the given string?
You are not, but your code should be elegant enough that it should handle that case.
Okay. So I guess instead of like doing all this possible blocks, an optimization we can make is if we ever encounter an element or like a string that's in the set, we would then kind of launch or like start another loop, and we would just continue going on until we either hit the end of the array. So I'll basically split this into array, and we would just, the moment we hit an element that is in the set, we would basically just start going, expanding the block we have until we have all elements in the set, if that makes sense.
Okay.
Yeah.
So sorry. So
yeah.
You found a block that said 2, 3, 4, right?
Yeah.
Now you said you want to expand. Expand what? At what point are you moving?
So let's actually make this clearer. So 2, 3, 4. Like I mentioned, I would split this into an array.
Sure.
And so initially I would just have one index looping, which is this one. Okay. I'm currently at 1, and 1 is not in the array. I moved to 2. I found out, okay, 2 is in the set. Okay. Now I want to find the block, right? So I'm gonna launch another loop. So here will be an I loop, and then here will be J loop, and I'm gonna go see 3. 3 is not in there. I don't care. I see 4, and so 4 is in the set, and I know it's not 2. So we have found two distinct elements that are in the set, and because the length of the set is 2, we know we have that block.
Yeah.
And so here we can return it. Now, if it was something like let's say this, or let's see, how do we? Okay, I think this would be a better example.
Okay.
We have 2, 2, 3.
Sure.
So another way I can do this is like say, okay, I launch the new array like I mentioned, and then I go on, I hit 4. Now this is a valid answer, but this is not the best answer.
Sure.
Let's see. I'm just wondering if I want to end it here and then have this index move forward, or actually shrink it at the same time.
Well, how do you know? You said before you have one loop, right? This is your I loop.
Yeah. Yeah.
And this is your J loop, right?
Yep.
So then, when do you finish your J loop? Do you just stop
I finished.
Here?
Yeah, I finished.
Okay.
So yeah, in this case, according to my previous example, I would just stop here because I have indeed found all of the elements in the set.
Okay, I see. So because you found it 4, you're gonna stop there and just move on.
Yeah. Okay. So I move on. When I move on to I is gonna reach here.
Okay.
Then I do the same thing again. This time I'm going 2, and then I'll just move to 4, and I'll just stop here because I again, fulfill that condition, and now I have another answer, and this answer would replace the previous answer because this answer is shorter than the previous one.
Okay.
Now I still feel like this is a little suboptimal because we are consistently kind of how do I say this? Consistently trying processing the same elements. For example, we already processed this, and then now we're processing, these all together again. Ideally, I would want to do something where I could, expand all the way to here, and then once I have a valid block, once I have a valid block of substring, instead of actually ending it there and have the I move to the next index and try the whole thing again. Ideally, once I have a valid block, I would shrink the second point, the first pointer.
Okay.
I would shrink the first pointer until it's no longer valid.
Okay.
And as long as it's valid, I will keep track of the new minimum.
Sure.
So initially we have I is say 1, and then we hit all the way to j is 1, 2,
Okay.
4. Okay. So for now we have an answer is let's see. Okay. It's 4 minus 1 plus 1. This is for the off by 1. So we have a length of 4. This is our initial answer. And then this is valid. This is a valid answer. So now I'm going to start shrinking I, or like the left index, and it's going to move I to 2. J is still staying at 4. Now this is also valid. So we can say we can update 1. This is 3 minus 1 plus 1. So it will be like 3. 2 plus 1. Yeah. 3 minus 2. My bad. 4 minus 2 plus 1. Yeah.
I get it.
So yeah, in this case, then I have answer 3. And then now when I get to 3, this is no longer valid. So I'm going to start expanding my second pointer again.
Why would you expand your second pointer?
Because it's no longer valid.
Right. Okay. So
in this case,
what's your first pointer tracking then?
So initially I was talking about expanding the second pointer once I hit the first valid element, correct?
Okay.
And that works fine if we have like 2 separate loops, I loop and then J loop. So it was kind of like I loop and then J loop.
Okay.
So now with this one, this would be better because I don't need to I don't need to always start J loop. I don't always need to start J from I plus 1 and then hit it all the way till I have a valid. So now what my new approach, well, not new, but we just talked about it, is that we'll have 2 pointers.
Okay.
And start is going to be at 0 initially. And then, so let's say, I'm gonna name these.
Okay. I get that. But my question is, you have a start, right? And then you said your I leaves off at 3, right?
Yeah.
And then you just push the J pointer like forward. But then it still doesn't make sense like what exactly I and J are tracking, because suppose that I have a 2 here, right?
Yeah.
Then what? Are you gonna keep scanning J over and over again? Like what exactly do you intend on doing here? Because I and J need to accomplish a very specific thing, right?
Yeah, I and J need to contain a substring that has all the elements in the set.
Okay, sure. So then, why would you expand J instead of I in this situation?
Okay, I guess I was just thinking of like, okay, once we have like 2, 3, once we are here, right, 2, 3, 4, we have a valid answer here. So I was thinking like, once I have a valid answer, I would then push I plus 1. I would continue to expand I until it's no longer valid.
Okay.
That was what I was thinking.
Okay, so why would you do that until it's no longer valid? Why would you do that?
Because my initial idea is that I was trying to find the shortest block. So if we have a valid block, I then want to identify if that same block can be shortened but still be valid. I guess that was what I was trying to think.
Okay, so then shouldn't I then point to a valid thing in the set then?
So that was what I was. So that was basically what I was doing. So I would like keep going.
Okay.
And then as long as it's still valid, like I'm initially here, right?
Yeah.
I is over here, and then this is valid. Right. So now I have a valid block. And then, like I mentioned, if I were to push I forward,
Yes.
I would go here.
Okay.
I would reduce this frequency, take out the frequency.
Okay.
So I know that at this point I'm still valid.
Okay. Sure.
So I would update the answer here.
Okay.
And using the same logic, because it's still valid, I'll move forward. And the moment it's not valid, I have to then expand J.
Okay, so then where do you expand J to?
Until I have a block that is valid.
Okay,
So in this case, I will reach all the way to 2.
Okay.
And now I have a valid block because I have 4, 4, and 2. And then I will do the same thing again.
Okay.
Expand I, this is valid.
Mhm.
And then again here, this is valid.
Okay, I get
the same answer. Yeah.
I get what you're doing here. I will say though, your rules are fantastically complicated, and I think there is a simpler way of doing it that still retains the core idea. The second thing I would encourage you to think about is how to expand this to n number, because it would be very impractical for us to, have like, 2, 4, let's say I had 7,
Yeah.
and then 12, or something like that, right? Do you intend on having like a loop, an ij for each one of the numbers in the set, or how do you plan on handling that? There's are two questions. Like, one is try to simplify this. Two, how do you handle the set?
So this is pretty similar to like a sliding window. I would have a hash map to store the valid elements we have in the current window.
Okay. Store the valid elements. Do you mean why the valid elements? You said frequency before.
Yeah. So it would store the. So I'm still kind of thinking here if I want to store elements that are not in the set. Does that make sense?
Okay. Why would you store elements if they're not in the set?
No, that was what I was thinking. So I'm still thinking, but here I said valid, so I would only store elements if they're in the set.
Okay.
So say we have the initial when we started I is 1, J is 4, right?
Mm-hmm.
Then the set would kind of look like 2. We have 2 of it, and then 4 we have 1.
Okay.
That makes sense.
Mm-hmm.
And then when I move I forward, 2 becomes 1, and then I move I forward again, we no longer have 2, and now this is no longer valid.
Okay. I see what you're saying. You're basically you're keeping track of the frequencies.
Yeah.
Yeah. So I think, okay, now I understand where the confusion is. The confusion is that you're not being as detailed in your. I would say if you just did a frequency map, I think it would be a sufficient way to describe it. So just keep that in mind, that what you're writing is a little bit off of what you're actually doing. Just as a key pointer. But I get your idea now.
Okay. Yeah, essentially frequency map to keep track of what we have in our current window.
Okay.
And we will update the answer as long as we have a valid window.
Okay.
Contains all elements in the set.
Okay, sure.
So this is pretty much the high level idea of it.
Okay.
And are you okay with this approach, or would you want me to further optimize this before we start
so let's
talking
see.
about coding?
You have a frequency map that will keep track. So you have 2 pointers, right? So your algorithm is basically that you're going to have a start pointer, and then you're going to iterate until you find an element that's in the set. And then what?
So that was the okay. I think it's best for me to write it down to avoid confusion, because
because you're talking. I don't know which idea you're talking about anymore. I thought that I got it, but then now I don't know. So.
Okay, so we have 2 pointers initially.
Okay.
I'll name them start and end. So they kind of indicate our the length of the window. Start is gonna stay at 0 initially.
Okay.
End is going to expand.
Okay.
As we expand, we save elements into our frequency map.
Okay.
If they are an element in the set.
Sure.
Okay. Okay. Now, when we have a valid window, we notice when we have a length of map is same as set.
Sure.
We can then start shrinking start.
Okay, I see. Okay, that's a fair algorithm. I understand what you're going for.
Yeah.
Perfect. Now that you've written out that, I understand perfectly what you're going for. I will say though that this is fine. I think you can do a little bit better, and I'm going to help you a little bit here. So, my question is, what really matters here when picking a start point?
An element that is in the set.
Okay, so
Yeah.
does that mean that you can be a little bit smarter about your iteration? Instead of iterating through every single element, you can
start jumping to the next element that matters.
Yep, that's an idea I think you could run with.
Okay.
And so, do you understand why I'm asking you to do this?
When you say do this, do you mean optimizing this, or do you mean like just jumping the index? Are you talking about my
because like you said, the only elements that matter are the elements that are inside the set, right?
Yeah.
So if instead of having the entire block, you just knew the positions of every single element inside the set, could that be sufficient enough for your purposes?
Yeah. That would be sufficient. I'm just trying to figure out how that will work.
Okay.
Okay. Wait.
That's fine.
Sorry. Yeah. So in this example, if I were to keep track of the indices, what I'm thinking right now initially, I'll kind of have something like this.
Okay.
So this is fine. This is an easy example. We can jump from. So I know like storing the indices would help. I'm just trying to think. I'm just thinking like in what way can I store them such that I'm able to kind of move on.
Okay.
Okay. I'm thinking like, okay, if I have a set of indices without caring what element it is, say I have 1 and 3, would that help? So, okay. So initially what I'm thinking right now is that once I have all the indices of the elements in the set, so I don't really care what element this index points to. I just care that this index is pointing to a valid element right now. Start will point at the first valid element, and will continue through this. I guess I guess it shouldn't be a set because I wouldn't be able to move on. But like, yeah.
What if you knew every single location of 2 and 4 instead?
Okay, let's see. If we were to have the other example 2, and then this would be 3, 4, then I could kind of start iterating using pointers with the respective arrays.
Okay.
So I'm just gonna write it down here. So I have 1, 2, and I have 3, 4. So this would be kind of similar to having like as many pointers as elements we have.
Sure.
Does that make sense?
Okay.
So initially, I would say, yeah, pointer 1, I would be pointing at the first element here, and then pointer J here. Mm-hmm. Now, 1 and 3, this is already valid. But then, like, if we have more, and say, say we have like 3 elements, and I'm just making up the indexes right now. This could be 0. Mm-hmm. And then this could be 10, 11. Okay, I guess just by looking at this, we know that the answer is going to be 0 to 10. Mm-hmm. Now, if we were to have 4 different pointers, 1, 3, 0, 10. How do I say this? I know I need to keep track some kind of maximum minimum. So let's see. I have 1, 2, 3, 4, 0, 10, 11. Initially, if I were to have a pointer point to the first of them, I would have 0, 1, 3, 10.
Okay.
in this, if I know the max and the minimum, which is 0 and 10, I have a valid answer, right?
Sure.
0 and 10, valid answer. Then I will move on if it's still, so if it's already at the end of the list, then it shouldn't need to move on anymore, because we should keep it there because we still want to keep it in the same block, right? And so this one has another one, so I'll move it to 4. This I'll move it to 2, and then this I'll move it to 11. Now the answer is going to be 0 and 11. This is valid, but this is not shorter. So let's find an example which this may. I'm trying to find a better example that would work when we see. What if this was 2, 0, 1? Okay, I think this might be a better example. So we have the same thing here. Initially, we're going to be pointing at 0, 3, 2, 10. If that makes sense.
Okay.
So initially we have 0 and 10, so this is valid. And I would then move this to 1, 4, 11.
Okay.
Then we will have 1 and 11. So I guess I shouldn't move them all at the same time. If I have 0 and 10, I move the 1. So if it's 0, 3, 10, okay. I know 0 is the minimum.
Okay.
I'm thinking, okay, this may not be the most optimal, but I'm thinking like, okay, once I have like, I would start at the first index of all pointers. I mean, sure. Yeah. So I have one pointer start at the first index for all these indices.
Okay.
And I know for sure that answer is going to be valid, right?
Yes.
And the minimum maximum is going to be valid. And ideally, in order to shorten it, I should increase the index that is at the minimum,
sure,
if possible. So right now the minimum is 0. I should try to increase it. In this case, I could increase it. I would do 1. Then the next answer is gonna be 110. This is valid and shorter. We will update the answer.
Sure.
And in this case, we would still continue because we haven't hit the ends of all of the indices yet. So 1 is the minimum, but it's no longer, I can no longer increment it anymore.
Okay.
So I guess I'd go to 2.
I would.
3.
Okay. So let's put it this way.
I don't even know if it's possible anymore.
Hello? Can you hear me?
I don't even know if it's necessary for me. Yeah.
Okay. Yeah. So it might not be necessary because what does it mean if there is no frequency? If there's no position?
Sorry, say it again.
What happens if there is no position? What if after this? What does it mean?
This is the last of that element,
yes.
And we no longer need to continue. So, because initially I was thinking like, okay, this is done. What's the next minimum? 2. I would see if I could increase that, but then that wouldn't make sense anymore because this is already the minimum in the range. So like, no matter what other elements we increase, it's not going to help us get a better answer.
Okay. That sounds reasonable.
Okay, so I'm just going to summarize this in text.
Okay.
So, given that we have a hash map that stores the indices of each valid element, we just need to have one pointer. I guess, do we even need one pointer at each of them? I guess we only need the yeah, I guess we would need one pointer at each of them. This element in the index array. Keep track of minimum and maximum. We increase the minimum until we no longer have more indices to continue. This works in this example, but I kind of have the paranoia that this may not, like, there may be edge cases where this current algorithm wouldn't work.
Okay.
If that makes sense.
Okay, so you have paranoia, then how would you prove that your solution is complete?
I need to define meaningful test cases to help me out on that. So so this was fine. Now say if this was 5, this was 1, this is 4. Okay, yeah. So I guess initially we would have this. Actually, would this be a good example? Yes, I actually think this will require this might be a good example. So we initially have 0 to 10. This is a valid answer. Now, according to the approach we discussed here, I would have I would just increase the pointer for the minimum value here.
Sure.
And the minimum is 0. This one, so I'm going to increase the next, and it's going to go to 5.
Okay.
Now this is no longer the minimum. And what is the next minimum? That next minimum is going to be 1. And then we have what, 1 to 10.
Okay.
This is also a valid answer. Move to 4. What's the minimum now? 2. 10. Okay. Then the next minimum is 4, 5. Okay. I guess this will work, but we cannot stop once we hit the end of the once we hit the end for this one. We need to keep going until we hit the ends for all of them.
Because why? Didn't we just say that if we go past the end, then we don't advance? Because remember that whole conversation up there. So I'm curious.
So in this example, this is fine because we hit 1, and we know that we don't need to continue moving on because all these are in between the range.
Okay.
Now in this case, if we were to use the same logic, 1, 2, and here. Yes. So this is a valid answer, right? 0 to 10, you agree?
Correct.
And now minimum is 0, and so we increase it just like we did up there, and now this is 5. And if we were to stop here, we would have 1 to 10. Okay. Well, I guess.
I mean, I see what you're saying.
Yeah, actually.
Go ahead.
Yeah, actually, no. I think I'm 1, 5. Okay, here 0 is 1 to 10.
Okay. Next
minimum is 4. Yeah, 4, 2 to 10. Yeah, do you see that now it becomes 2 to 10 becomes the answer?
Yep. Okay, I see. So when the moment that you're advancing something that's already at the end of that list, that's when you terminate. Is that what you're saying?
I'm saying that I need to reach the end. I need to terminate for all of these elements.
Oh, for every single one?
Because if I terminate it at 5 over here, this is not the correct answer. Because if we follow the same logic above, we terminate at 5. This is not the correct answer, right?
Okay, so then how exactly are you getting 2 and 10? Let me ask you that. How are you getting 2 and 10? Because you already have the pointer pointing at 1. And how does that work with your previous one?
So this is another example. So what I'm saying is that once this reaches once we terminate this one, we need to find the next minimum. The next minimum is gonna be 1. And 1 still has more indexes to go. And so we'll increase it. And
now it's 4. Yes.
Yeah, it's 4. Now we terminate 4. Because we're already at the end. And then we look at the next minimum. Minimum is 2. 2 is already at the end. Next minimum is 10. We increase it. Now 2, 11.
Wait. Slow down. You said 10, right? Yeah. And your algorithm has been so far to advance the minimum, correct?
Yeah.
So,
yeah. Sorry, my bad. Yeah.
That's why I said slow down.
What?
So you have 2 here, right? You evaluate. Yes. Now you have 2 and 10, right?
Yeah.
Now after that, what do you do?
I stop because once every time we make a change to the indexes, we find a new minimum. If that new minimum is already terminated, then we know we can stop.
Okay, you mean if it's at the end of the list?
Yeah,
That's literally what I said. So
yeah.
Okay, so I okay now okay, go ahead.
Yeah, I guess I was just like I was just a little off track because when we were on the previous example, I was more in the impression that once we hit the termination for one of it, like the first one, we can stop. But
Okay.
like yeah, I guess like the better way to say is that we increase the minimum until we no longer let's see, we keep track of minimum, we record the answer, then we increase the current minimum index.
Okay.
If the current minimum index is the last of itself, we can stop.
Okay. All right. So, all right. I think this looks good. Now, how are you going to convince yourself that it's complete?
I guess would it make sense to try a couple examples? Or
I mean, you've already tried 2 examples. What other examples do you need to try and convince yourself? What are you missing then?
Idea itself, I wouldn't say I'm missing anything. If anything, I would say like I don't have like like I'm not sure like the details at some of these steps. For example, one pointer at each item, and then we would have to keep track of the minimum.
Okay.
I think that's just kind of what some of the finer details that I haven't really thought out yet. But in terms of like the high level idea, I think this idea is fine.
Okay. So then, if you want to write the code, then go right on ahead. Otherwise, do what you want to do.
Okay. So are we good to assume that we are given the indexes, or like the?
No. Like I said, look at the top. You are given a block of text and a set of strings.
Okay. So I'm just gonna write a very quick pseudo code, just to feel more comfortable. First, we do one scan, record indices for each key element. Okay, once we have that, for all entries in index map, we need to know 2 things. We need to know minimum, maximum. What else? I need to know the minimum every time. Record answer. Then increment current minimum. Next, increment, we repeat the step of recording answer. How would I keep track of entries in minimum, maximum? Let's see. So I have 0, 1, 4, 10. I know minimum is 0, maximum is 10. If I have something like element and so I guess I'll have to use I have to store it element and index. Okay, because because this is what. So at this point, like if I have like smaller details that I'm not like fully 100% certain yet, but I kind of have a vague idea. Do I continue to kind of iron it out in my pseudocode, or
Well,
do
my
I
question is, well, what exactly is the problem that you're running into? Let me ask you that.
My problem is being able to increment, or like knowing which elements index to increment, and keeping track of the new minimum as we go.
Okay, so that seems more like a code problem to me. You already have the idea, right?
Yeah, I have the idea.
So then all I do is like how to write the code for that.
Okay. So yeah, that was what I was thinking. So should I be continuing to like work on the pseudocode, or at this point do you think like it's better
pretend
to
this is a normal interview,
of...
dude. Pretend this is a normal interview.
Okay. Then yeah, I'm gonna go ahead and code this out right now.
Okay.
Shoulders block. Let's see. I'm given a string and a say keywords. Initially, we have to build the index map. So index map. Yeah, and I'm gonna split the string. Once we have the index map, we have to then start keeping track of the minimum, maximum, as well as the different indexes. Okay, so let's see. For woman indexes misses in so have the trend didn't need to even no I don't. Maximum, I guess I should keep track of it there. No, wait. Wait, actually, it's this one. Okay. Okay. We have the maximum, minimum. Let's see, how would I, yeah. Okay.
Okay, let's see. Sure.
Answer,
Okay.
and then
Okay. That's a frequency map. Okay.
index +1. Okay. If let's see. I will push it back, but I have to keep track of the new minimum.
Okay.
0, 5. Let's see. If Okay, so let's see. How do I this? I think I have the gist of it. I'm just pondering on the termination condition and just being able to get the minimum effectively each time. So I have the first minimum. Okay, I guess. And let's see. Okay, let's see. I'm gonna run this through the example we have to make sure this works.
Let's see, min heap, heap pop, the length of the heap map is greater than index 1, heap push. Alright, you're pushing to a heap. Okay.
Yeah, the reason why I use a heap here because is I want to be able to get the element like the index that has the minimum value over here. So let's see. I guess this would be the let me just how do I get rid of this? Okay, it's fine.
So heap pop from min heap, yeah. Okay. So the answer is going to be the minimum of the answer that you have collected so far, or the maximum that you've seen so far minus. Okay?
Okay.
Okay, so then my question now is, how are you updating maximum?
I don't need to update maximum.
Why?
I have maximum here.
Okay.
Up here. So the reason behind this is that when I initially initialized the first pointer indexes, as in like, here I have like 0, 1, 2, and 10,
Sure.
right? And so the maximum pointer is already pointing at how do I say this? Because we need to include this element no matter what, right?
Uh-huh.
And so like further increasing it is just not going to really help.
Okay. So then you're stuck with a negative. Then wouldn't you be stuck with a negative number on this every single time? Because your maximum is always going to be 0. Or am I wrong here?
What? Wait, no. Wait, maximum is up here.
Okay. So your maximum is always going to be the first element in this index. Or yeah. Okay. And you're never going to change that.
That's why I'm testing it, because I'm also thinking like, what if I have something, I may have something that where I may need to update it.
Okay.
I'm
actually going to pull the plug on this because I know where your issues are, and I'm going to talk about them.
Okay.
So basically, for the sake of time, because I want to move on to other things.
Okay.
But here's basically what I took a note of.
Okay.
I thought your progression was fine for the first like 15 minutes. I think where you really started struggling was this idea of the frequency map and trying to express it in the indices. So if I had to, I'm going to show you here. So basically, you had a very difficult time understanding whether or not you needed a frequency map and how that really interplayed. And I think that's basically what you're struggling with here, as well as just a consequence of that, is that you're not really sure that when you were trying to explore the idea, there was a lot of like hesitation from you. It took you a long time for you to actually understand the idea, and then I still feel like you have this little habit of like, oh, what does it look like in code? And I think that until you understood what it looked like in code, you didn't understand what the idea at all. So I felt like you're going through the motions of it, but then you were still reliant on code to get the idea to click in your head. Is that about right?
So when you say I wasn't sure if a frequency map would fit in, is this on the first part when we were talking about before we even had talked about this index map?
So so basically what I was talking about. So let's go through this. So the first 12 minutes is you doing like the I and J. Remember that?
Yeah.
I felt like you didn't explain that very well. Like, why did you want to expand I over J? What is it supposed to do? And then like it took a while, but then I think that once you did an example of it, then it was fine. So I understand that, but I think that for some parts it was like a little bit difficult for me to understand exactly what's going on through your head until you did like an example. So and the fact you did an example, I think that dissolved that, but it's just like it's like at least you have a tool to diffuse that. But it's like a lot of times I felt like I was getting a little bit lost. Like once I understood what you're saying, like, oh, I completely misunderstood exactly what you're doing. But what I'm saying here is that for instance, when we were doing the whole idea of like, hey, what happens? What if you don't have to iterate through the entire array? What if you just knew the positions of the elements in that set?
Yeah.
That was the part I think you had a hard time really understanding. It's like, you get the idea, but there's like, how does that help you? I think that's where you really struggled on how to actually use it, and I think we had to go back and forth a few times on the explanation of, well, you need to advance the minimum element, and then when you get to the last element of the of a particular frequency or like the positions, and then you have to advance again, that's when you terminate.
Yeah.
I think you really struggled with that idea because you didn't quite understand it yourself, and then only until you like did like a few examples of like, oh yeah, this is actually how it works, then you understood it. So I think you lost a lot of time just trying to understand the idea, and the reason why I think you struggle with it is because you're still trying to translate into code in your own head. Is that about right?
No, actually I was losing time on like the I guess like the paranoia on like the edge cases, and just like I would say like it was more on determination on like when do we determine like, okay, we no longer need to continue.
Okay.
Because when I first tried the first example, like it was like fine, and I was like, wait a minute, it could move to a different index, and then we need to have a more clear answer on like when do we stop.
Okay.
And I didn't really start thinking about the code until it was time to code. Until when it was time to code, I was like, oh, okay, how do I actually represent that in code? And that was where I like spent some time as well. But I think like I was more on like having a clear idea of like when to stop.
I see. So yeah, okay, so that's a different issue. All right. So basically, the bottom line is that remember what I said before about like, hey, each step is going to be like a branching factor, right? There's going to be like, maybe if the elements between elements 1 and 10, 11, 20, 20, 30, you can define those each in terms of like states and branches. And as long as you can simulate going into each one of those branches and with different inputs and variables, then you achieve complete coverage. In this particular case, your first thing here is like scan for record indices for each key element, right?
Yeah.
So then what happens if none of the elements are, it's like either all the elements are in the set or some of them are or none of them are. So that's the first test, right?
Yeah.
Second one is being able to do this whole progression here. Like let's say that every single element has at least one thing. So then now you need to test what's called moving a minimum up.
Yeah.
In a particular position. So as long as you can test the minimum moving up, then you're fine. And then the last part would be if that minimum goes out of bounds, can you terminate? Those are really the only like positions that you need to test. If you can handle that, then you're fine.
Yeah. Yeah.
So
that was basically. Oh, sorry.
So I'm saying that that's the only thing you really need to worry about. That's would prove to be completeness in test. Now this code is not now when you said hey, I don't really know how to translate this into code. Well, all you really need is just a pointer to the list of each one of these. So the way you would express this, let's backtrack a little bit. So suppose we had a list of every single element and their their corresponding, right? So let's say I word 7, right? And then I would need a 0, 5. This would effectively just be a map of string to a list of integers, right?
Yeah.
And then the way I could represent that is I would also have a map of string to integer to be my positions, to my pointers. Wouldn't that work?
But then you need to recalculate the minimum pointer every time once you move it forward.
That's fine. I mean, like, you just take, like, the whole, every single integer in the map, and then just, like, calculate the minimum, and then whatever the minimum whatever integer that corresponds to, whatever entry, you just override it. You just do a ++ on it, right?
Yeah. Yeah, that's fine, but, like, I had that idea. That's fine, but then, like, I didn't want to reiterate the whole list of pointers to find the minimum pointer each time, if that makes sense.
That's fine.
And that's why I ended up with the heap approach.
That's fine. You can do that as well. Yeah. My point is that I feel like you're still trying to skip some steps. I think if you just said that here's the basic idea, and then like, okay, we want to be faster than this, that's fine. Because I felt like you struggled really to write the code, and I think it's because you're trying to optimize in your head.
Okay. So, yeah, because I had this idea of like, okay, because this was the whole idea we talked about, right? We have pointers and we increment the pointer. And I already have this idea of like, just keep the track of the pointer, we increment it, and then we then find the minimum again. But then I was like, okay, I guess I didn't like write it out or like talk about it about like, oh, I actually don't want to reiterate the whole list of pointers to find the minimum pointer. Because then what if we have like, the map of pointers could be like 100 pointers. I don't want to iterate through 100 pointers each time and try to like end up with the heap. But yeah, I guess it was just like me trying to optimize that without fully talking about it.
Right. So that's another thing. And don't ever do that. Like your idea has to be rock solid.
Okay.
And remember, you imagine this way: your code, you only got to write it once.
Yeah.
One clean stroke following an idea. So do whatever fuckery you need to do in the idea, but when you have to write the code, you're committed.
Okay.
You only get one shot. The thing with like you only get one shot at writing the code. So, but the bottom line, I think, is you're not to do too bad. I think the 2 points like what is don't be paranoid about the test. Get the idea down, and then test the states, revise the idea if it fails, and then retest. It's just a cycle of, hey, I have an idea, let's test it, and then let's update the idea if it fails the test. And making sure it doesn't break the previous test. That's it.
Yeah.
As long as you focus on the path and the steps, because you have you have all the keys to doing it. There's no need to be paranoid.
Okay.
All you have to do is just trust the process that you use to get there.
Okay.
It might be a little bit slow, but
Okay.
it'll be complete, and you won't miss a thing. And in the end, that will be faster as you keep thinking about it. You know, but don't focus on like, oh, what if it doesn't work? Well, then the steps you should be thinking about is what does it take to prove that it does work? That's it. That's the first thing.
Okay.
The second one I want you to focus on is that hey, don't think about the idea going into the code. Your idea should be solid. So if you feel like you need to write it down, that's fine. You can always erase. You can always strike out and then move and say, hey, this is a faster way of doing it because this is not optimal. You know, because notice like this entire problem. We did a lot of revisions. We did naive solutions. We optimized on those naive solutions. We kept going, right?
Yeah.
And that's really the whole premise of this problem is for you to keep repeating that exercise over and over and over again until you arrive at an optimal answer. In fact, like I gave you a few hints that I kind of rephrased poorly. I could have said something instead of like, oh, well, do you only need the positions? I could have said, well, what happens if it is very sparse?
Yeah.
Yeah, that's another thing there. I mean, I helped you along because I wanted to really, I really wanted to try and poke holes at where I think you would have had problems. And so basically, I think the whole thing boils down to your idea needs to be simple and clean and discrete. You need to be in discrete pieces because if you can handle blocks individually and then say, hey, I've solved this block, I can move on into the next piece of the code or the next piece of idea.
Yeah.
So I think it's just being able to get that execution down. You're doing all the things mechanically right. Don't get me wrong. The problem is that you're not doing it, you're not tying it together in a very smooth way. And I still feel like you kind of run into like hiccup after hiccup after hiccup. But you will get the answer if I gave you enough time. That's the thing. So at least we hit that point. What I need you to do is make it into an instinct as well.
Yeah. Yeah, that's the other thing I noticed during practice as well. It's just like, you know, eventually you could get there. It's just like, I guess other than like being able to simplify my idea, the other thing is just like being fast enough. Yeah, like I feel like because I'm not like going by like smoothly enough, and so I may end up like slowing myself down. That was the other thing.
Yeah, and I think the part of it is that you seem mentally wound up when doing these problems, and you're just like, oh, what if this happens? What if this happens? You know. And the fact is that I think you have the tools. You can do it. You've shown here that you can do it. But it's a few factors I think go on. One is that you've been focused on too much on the mechanics that you haven't really tried, you know, letting instinct take over. Two, you have a few other things going on as well, work-wise, and then it's just like all coming together. And then three, we've been practicing for so long that it's just like, oh god, you just like feel totally tense. So I want you. So this is like where it's coming through. What I want you to do is actually to take it easy this week. I want you to try and actually solve the problem as if you are an engineer. You know all the pieces and let the pieces come to you naturally.
Okay. Yeah, I think the you did say it right about me, like very focused on like the mechanics and like the approach. And I guess like sometimes that kind of bites me because I'm so focused on like doing all the like having like checking everything on the list, and then it kind of like in some way affects how I approach the problem.
Yeah, no. Don't get me wrong. You do need to have that paranoia when practicing, but at some point you've practiced enough that it's become second nature, and I think you have that nature. It's just that you're actively like being paranoid about it, and it's like it's hurting you at this point. So right now we're gonna make that jump, and don't worry, it took me a very long time to make this jump myself because I'm very mechanically inclined. I don't have a lot of, I would say, instinct for a lot of things, and that's why like I will repeatedly say that I am not a genius at anything. I just worked really really hard, and so if you have the same problem, then it's gonna take some time for you to let go, let the thing just mechanically just happen. But it's really important for you to just like let go and just relax. That's all I can say, and to let things flow naturally. And if it doesn't, and it's like if you fucked up, you fucked up. You can always do it in post-mortem. You can always figure it out and adjust later, and then try again. But the point is to let the engine run, let it do its thing, and then fix the engine a little bit when and if it starts like having some issues. But when it comes down to actually doing the problem, let the engine run.
Okay. Yeah, I definitely do feel like, tense when I'm like doing it, even though like yeah, it's like I don't feel good. It just doesn't feel like I'm like relaxing.
No.
If anything.
Yeah, because you're too busy trying to check things off, which is fine when you are looking back at the problem. But when you're doing the problem, you have the pieces. Just let it go. Let it run.
Okay.
I think you will see like a pretty drastic improvement. And
Okay.
and if you do that like for a week, I think you'll be pretty good. So I
Okay.
would say you're 80% of the way there. 80%.
Okay. Okay. Sounds good.
So don't worry too much about it. All you do is just let go, let that last 20% ride itself.
Sounds good.
Okay. Next thing I want to focus on is a system design. So
Okay.
I wanted to actually do another problem with you. Do you have bandwidth for that, or are you feeling a little gassed? How are you feeling right now?
Let's just take a 1 minute break. I think I could do a problem, but it's just I didn't really get to practice much of it. But I think like doing system design, I feel better about it. I don't feel as tense doing it, I guess. Because it's more like just talking through like what I have now, and then yeah, and I kind of want to practice the stuff that we talked about on Thursday. So
Okay.
I'll take a yeah. Let's take a 1 minute break, and then we'll continue.
Sure, I'll get some water myself.
Okay.
All right. All right, let me know when you're back.
Okay. Yeah.
Okay.
Good to go.
Cool. All right. So let's do a system design one. I assume you're still focused on product.
Yeah, but then I'm gonna, but Uber doesn't do that, right? And if I were to try for L4 at Uber, then
I think we do. I back don't. I'm pretty sure we have like a product version.
yeah, but then I'm not sure like if the interviewer decides on the spot or like like if they decide on the spot, then it could be a classic. So I'm
Okay.
not entirely sure.
Okay. Since Facebook has been our priority, let's go ahead and shoot for the product, and then, I think the feedback that you got from the guy last time, I
Yeah.
think was extremely helpful for pinpointing some of your issues with the classic. But if
Yeah.
Uber, you are going to talk to the recruiter on Friday,
Yeah.
so we'll get more information then. And then from
Okay.
there, if we need to pivot, we can. But
Okay.
for the most part, let's focus on our original objective on Facebook.
Okay.
Okay. All right, excuse me. Let me go find a problem. Let's see. Okay, no wait, this one's too hard. Hold up. This one's gonna be way too hard for you. Okay, now I've already asked you. We've already done Facebook newsfeed, yeah?
Did we?
I mean, I could get you know, we could do a newsfeed one. I think we did
Okay.
like update posts on visibility, but
Yeah. I don't think we did newsfeed. I mean, I did a newsfeed API with my coworker, but I don't think we did newsfeed. Like we first did Tinder, and then we did the CI/CD.
Okay.
And then we did like the rewards program.
Okay.
I think those were the three we did. I don't think we did newsfeed.
Okay, we did rewards program. Because that one, like the other ones are leaning a little bit more towards classic system design. Excuse me.
Yeah.
Yeah. So I probably have to think of a problem off the top of my head. In order for that to happen.
Oh.
Sorry. Go ahead.
Yeah, I guess we could go with something that maybe like a mix. So like, you know, it doesn't have to be like fully product. It could touch upon like some classic. I don't know, like whatever you. Yeah.
Okay, so then let's do this. Let's do this problem then. So I want you to design a almost real-time likes counter solution. So you know on Facebook, you know you have this like you like the post and whatever.
Yeah.
And then eventually, you will see like that counter tick up in real time almost, right?
Yeah.
I want you to design that portion of the system. Or I mean,
okay.
The like button is technically a product, so.
Okay. And like, is there like a certain amount of clicks that we're expecting per minute, like per hour? Is this something that is going to be a pretty large?
Consider that we have 1 billion daily active users. So some posts can get a lot, some posts can, you know, maybe not get a whole lot.
Okay, 1 billion. I guess we can say the range of like lights could go up to 100K per minute on a post. Let's see, what else do I need to clarify? And I guess like this would just be a generic solution to keep track of the lights for any type of content, right?
Mm-hmm. Yeah. So I mean, you're familiar with like your posts with like, you know, comments, like comments themselves, posts, anything.
Yeah. Is a user able to like a post more than once, or is it like they can only like it once?
Can only like it once.
Okay. Can they unlike it?
Yes.
Okay. Can like once and unlike. Okay. So I guess like what it would look like is, you know, we have a lot of users looking at lots of users looking at the same posts, and I assume like this like counter, it's gonna be almost real time, and so this is gonna be updated in almost real time as well, right? So the counter is going to be updated regularly without needing the user to refresh. At any time, they can click like or unlike, and it should be reflected immediately on the front end. Let's see. So, okay. So what I'm thinking is obviously like every content. So let's just say for now, for simplicity, we can say post. This could be anything. If we were to scale up, this could be a page, a group, or like a comment. But for now, let's just, for simplicity, we can say this is a post. We obviously will have a rights. I guess we need to keep track of two things, right? So one is the amount of lights, and I guess we would also say, what we say like by, okay, I kind of, do I want to keep it on the post itself? So I'm thinking of like, you know, I could potentially store like the lights on the post, meaning on the post itself, on top of like this integer, like total, this would be an int, and then we have lights, this would be edges, user. So I was initially thinking something like this, but then this wouldn't be very effective because that means like every time a user clicks on something, likes on something, we need to create this edge, and then they could unlike it immediately, and we need to delete that edge, and it may not be very efficient if we'll have to have like a high amount of lights and unlights at the same in a short amount of time. So I guess for now, like let's just go with amount of lights, and in terms of storing the actual, I guess we would store it on user and like post would be edges to post. Okay, and unlike we would just remove that edge. Yeah, okay. I guess like we would deal with like two main entities here in the database. One would be a post, and then second would be user. The post would have a total like count, and then the user would have a list of like posts, which is basically just edges to post. I guess what it would look like from a user's perspective is that I guess I already mentioned it above, but let's just summarize it again. Users can see a list of content, aka posts, and they can see the numbers updated frequently.
Okay, sure.
They can choose to like or dislike any post at any given time.
Sure.
This should be reflected on the front end immediately after their action. Okay. So this is yeah. So from the front end, this is basically what it's going to look like. So now how we're going to be able to determine if a user can like a post and stuff like that, and what is the like count going to look like, how these updates going to propagate. So I guess like initially like serving the content, right?
Sure.
Backend needs to serve a list of posts.
Okay.
Now, typically, like we have like these posts we already have a like count. And typically, like I guess like with how things work in web apps is that they have API endpoints, and you can call that API endpoint to make a certain change. But I guess in this scenario, because these changes can be happening very frequently, I guess like making each like an API call wouldn't be very efficient, right? So I was thinking of like something more like a WebSocket, where we have I'm just kind of thinking out loud right here, but I'm just thinking of like having like a long-lived WebSocket connection in order to display almost real-time updates.
Okay.
And so when users like a post or dislike a post,
so these long-lived connections, are these only for people who like posts or for people in general?
For users in general, when they log in, they should have like the WebSocket connection open, and then how I'm kind of picturing this right now, I'm not sure if like this would be optimal, but for now I'm thinking like when a user logs in, we will open a connection.
Okay.
And they see a list of posts, right? Because the backend will serve a list of posts.
Correct.
I'm gonna write this out. So backend, okay, and then connection for each logged in user.
Okay.
And we will only have one connection. And when a user hits like what I'm thinking would look like is that we will have some kind of a message queue. And this, what we would feed into would be, say, post ID, and this could be like or dislike. Let's see. Should I say, yeah, I would say, yeah, like a dislike. And this would be a queue, and then this feeds into, the backend, and then we can then immediately update the counters.
Okay.
user have some kind of message queue. Okay, and the front end will have certain responsibilities.
Sure. Okay.
Because we're feeding into a queue, and these updates may not happen immediately in the backend, but on the front end, we may want to kind of display the update.
Okay.
As we add the message into the queue, just to give the user some like sense of like real time. And then the other thing is that the front end needs to be aware of the user's like posts. So that way we can we don't allow them to continue liking the post.
Okay.
Same goes for dislikes. So dislikes would just kind of be a toggle, and then we would just toggle that and then send that to the same message queue and stuff like that. And so this was that's kind of what I'm thinking would kind of look like from a user story perspective. User logs in, we have a connection open. These posts will have, each post will have a like count, and the like count will get updated as we process these messages in the message queue.
Yeah.
When a user hits a like or a dislike, depending on like what the current status is, and that's going to be the front end is going to have some
okay
gate
so
logic.
Then what does this
that.
all look like on the back end? You say that the likes and the post will have edges to post. How exactly are all the components in the back end going to be what's it called arranged, and what responsibilities do they have?
Okay. Yeah, I'm just trying to see how do I kind of get. I don't think I can draw easily on docs, but let's just say we have user. How do I user and then we have front end, and say we have a message queue. Let's see if this is there a way to draw better on. Let's see. I think drawing. Okay. I guess I have to talk about the different flows separately. But what I'm thinking right now is that the user logs in, then we open a connection, and they basically hit likes, dislike, and then it goes into a message queue, and then it goes into the backend. So for this particular part, as we process messages from the queue. Okay, I guess like another thing we would need to add here as well as we iterate right now is the user ID. We need to do, let's see, update the user's like pose, edge to the pose, update the post's counter, and yeah, I think that these are the two main things we need to do. And I guess we don't have to worry too much about messages coming in concurrently, because this is somewhat of an item. I wouldn't say, yeah, this is a safe operation to kind of keep doing, because it's essentially just incrementing the counter. And if it's a light, we just create an edge to the post from the user. And if it's a dislike, we know that edge is already there, and we just need to remove it.
Okay, sure. So then what does the database look like? You basically are funneling every single like and dislike through a message queue.
Yeah.
Okay. So then my question is, what does the databases for these look like?
Sorry, say it again?
So what are the databases for the likes and the posts going to look like? Are they in separate databases? Are the likes and posts going to live in the same database table? How do you plan on doing this?
Okay. Right now, let's see. We have a message queue, and then we could potentially have like different topics. Let's see. I'm just trying to think of starting from the message queue all the way to the backend. Each topic can look out for a list of posts, then they would all eventually come to, okay, I'm guessing like with the amount of likes we're getting, we need some kind of load balancer to balance between application servers to actually process the message. Now, in terms of the backend databases, let's see. Okay, a post. Okay, we have a lot of posts, right?
Okay,
And
well, you're talking about
saying,
different topics. Load balancer between applications to actually process the message. Okay, but then, like I said, what does the backend look like? What do your database schema looks like?
Okay. Do you want me to talk about like, as in like the entities like schema, like what kind of views they have and stuff like that?
Exactly.
Okay. I just wasn't quite sure. So posts will obviously have a post ID. We'll have something like content. Let's see. This could be. Let's say we can have media. This could be let's just come back to this. We can talk about images later, but for now, let's just say we only have a description.
Okay.
Would this be a string? This would be an int. Let's see what else. We have a likes count.
Okay.
This would be in, and like I mentioned, I'm not thinking about at least as of now, I'm not thinking about storing the likes edges on the post itself. And user, we have a user ID, name.
Okay.
And then mainly we have a like post, edges to post. And I guess like at this point, post doesn't have an. I'm just wondering if I would want this edge to be bidirectional, and have an inverse edge to user, or if one like a one-way edge is sufficient.
Okay, I will stop. Let's stop and think a little bit.
Okay.
Excuse me. So, you are giving a user every single liked post as an entry in that database. Why?
Sorry, say it again. I'm giving the
You are giving a user every single liked post is in a single entry. I assume like some kind of object.
Yeah.
And you are going to do that for a post. Why? Why would you do it this way?
Okay. Yeah, like initially I guess like now that you mentioned it is kind of inefficient if we need to serve or like when we return the user to the front end, we need to return like all of its posts that it has liked. Initially I was thinking like the usually more straightforward approach is that we say like by users over here and edges to user.
Okay, I'm going to put a pause here because I think you're just randomly spitting out answers. Remember, what's the user story and the inefficiencies? Use that as your compass and try again.
Okay.
What's inefficient about this?
It's inefficient because we are returning unnecessary data.
Yes.
Oh, too much data. So if we don't store edges, we still need to know if a post was liked by a user.
Yes.
On the front end.
Yes.
So if not storing on the user, I guess the only other entity we can store on is at the post.
Or
the front end itself.
Or
we can have a new table.
Seems pretty reasonable to me. Why would I?
Okay.
Why? Wait, whoa, hold on. Don't take my answer for it. Why would we do a new table? Why would this over anything else? Let me ask you that.
Okay, so right now I'm thinking like, because we have two basic approaches. One is storing on the post, one is storing at the user. But these two require constant updates. So if we store at the user, we need to return a lot of data every time the user logs in. If we store on the post, we have to make a lot of updates to the post, because then a post could be like up to say 10,000 or like 20,000 per minute or per second. Okay. And we basically have to write to that same post that many times, and
Okay.
that's just not ideal.
Okay.
So we don't want to start the post, we don't want to start the user because we don't want to return unnecessary data. The only other way is that we store this relationship separately through a table. And that's why I'm thinking about storing it separately.
Okay. Sure. That's a reasonable answer. Yeah.
Yeah. So I guess what this would look like is that we obviously have a ID for this like relationship. This would just be a UUID, or we can say int. This would be consistent with what we have above. And this would have a user ID and a post ID, just to say what user has liked what post, stuff like that. So when we process a queue, process a message from the queue, we just need to basically add a new row to this table.
Okay.
Adding the user ID and the post ID, and that would be a pretty quick operation. It's almost like
Sure.
we just appending to a log. So that would be pretty quick in terms of like creating new lights. Now I'm just like thinking how this would work when we do this light. Do we append?
Well,
yeah.
Let's also consider. I mean, likes, dislike, like you said, it's just gonna be addition and removing of you like posts. My question now is, well, you have this like count on the post, but it's really an aggregation of user liked posts. So how are you gonna handle that? How do you synchronize these two?
So I have this initially because we don't have this table. Now I'm wondering if we have this table, do we still need the lights count? If we have this table, we can basically check how many rows share the same post ID, and we know, like for a certain post ID, we just need to know how many rows are in this, and that from there we know how many lights a certain post has. But would it be efficient to look at this table every time?
Yeah.
If we were to store it as a different field, I guess like we would need some kind of regular updates to sync this field and this. I'm guessing like just having a simple process of like checking in every like 5 to 10 minutes and just updating the post, but then some posts may not have updates every 5 to 10 minutes, and we might be just creating like a lot of unnecessary. So because we get the messages from a queue, we know what posts we may have processed in the past like 5 to 10 minutes. What if we rely on that to determine what posts we need to then synchronize?
Okay, what is the trade-off that you incur doing this though?
You mean having the message queue like keep track of what's?
No. Like you said, you want to delay the updates to the like counter by like every 5 minutes. You want to get all the like posts and then update the like counter or something like that, right?
Yeah.
What is the trade-off for doing this?
The trade-off is that, well, one is this is always going to have a 5 to 10 minute lag, no matter what.
Yeah.
That's definitely one trade-off. So the backend will not have the updated information, even if the front end is updating it itself.
Front end, back end, I think you're mixing up the terms. These are both tables. So these are both back end.
Okay. So yeah, and then I guess like batching it every 5 to 10 minutes. I guess the main concern is that we are having a lag, and then also just processing a lot of updates at the same time.
I'll make it easier for you. You basically do not have the real-time likes. You're gonna have a delayed real-time like.
Yeah.
It'll eventually be consistent, but you won't it won't be live.
Correct.
So that's what I think you need to be able to explain that idea very easily, very simply. And right now I'm seeing that you're kind of like taking multiple shots, trying to dance around it, but you don't actually have a clear idea of what you're giving up for it. Anyway, so that's something else I would note. Okay, so then my question next is, well, how are you gonna post these? Two things. One, how are these posts gonna be stored? Two, how do you know which posts to give the like subscription, the like to, the like updates to, and not to.
I'm not quite sure if I get your last question.
First, okay,
You said,
what I mean is that if I'm scrolling through Facebook,
yeah.
I don't need the like feed for every single post that I have ever seen, that I have ever, liked. I don't necessarily need that. So, how do I make sure that I get the like updates that are relevant to me?
Oh, okay. I initially thought the user will want to see the lights for the for all the posts. That's why I was kind of going for.
Okay, every single post that I've ever liked and seen, I want the updates for.
Okay, I know. I was initially thinking like just every post in general, like even if you did not like the post.
Okay. Let's run with the idea. Why would I want to do that? And is it? Let's say, why would I want that? And maybe I do want that, And maybe that's a design decision that you say you want to argue for. What are the benefits and trade-offs, and is it worth it?
So benefits is obviously like having an overview of like everything going on. You can see the lights increasing, decreasing. It's almost like watching a stream, but like with multiple things going on.
Sure.
The downside is that a lot of those may not be relevant, and like the user may not care about it.
Okay.
And we're doing a lot of unnecessary computations and making things. I would say like almost real time will have like will incur like overhead, and just like we have to do a lot more processing to make sure like these are almost real time. And I guess like it would be a lot of waste of resources if the benefits of doing so do not counterbalance.
Okay, right. So that's why I'm asking you to do the trade-off for me. What is it? Is it worth it or is it not worth it?
Not worth it.
Well, I would say, and don't be so hasty. I would probably do a back-of-the-envelope calculation for that.
Okay.
Anyway, so I want to stop here, give you a little bit of feedback. Basically, with 10 minutes we have left. So, first things first, I noticed that you are still, I want to say you need to be led in this discussion. That should not happen. You should be leading the discussion. All the questions that I've been asking, like, are the trade-offs? How are these being stored? What's the next logical thing? Remember what I talked about last week? You should be able to anticipate what the next question is going to be once you suggest an answer. I didn't get that from you. You should know, like, immediately, once I make this decision, here's the next question that I have to answer, right? So, the first things first, like, let's go through, like, your answer. The first thing, you define what you wanted. I think that's fine. I would also be a little bit more explicit about functional and non-functional requirements.
Okay.
It's just like another compass for you to use. I don't mind what you did here, but I think that basically making a saying what exactly you want out of each component and what you want out of your system is going to be a little bit easier for you instead of like trying to come up with all these random things. I think this will give you a little bit more structure. So, for instance, one of these things could be like the Cap Theorem. What two components of the Cap Theorem do we want to take? In this case, it would just be AP because we're willing to sacrifice some time on the consistency in order to achieve accessibility and the other two, right?
Yeah.
So, partitioning and whatever. So after that, we would want to let's go. Now you start drawing this out, right? And so I think that's fine. Based on like what the fuck we got. What's it called? It's kind of hard for us to draw, right? So I'm fine with this. But then I like the message broker idea. You're starting from front end. It's like, okay, well, all these messages we need to process. It's like we need to process all these user activity, right? My problem is that, well, how many queues are you going to have? How are these going to be done? Like how many these are not obviously all going to go into every single pipeline. So it's like, okay, you're updating the users liked posts, fine, and then you're updating the post counter, okay, fine. But then that begs the question: how are each of these done? Are you going to do it at the same time? Are you going to, I think it's like you committed yourself way too early.
Yeah.
This is just way too early to commit yourself to. The reason why is because once we actually did this exercise of like, oh yeah, we want to store all the user-like posts into this thing. Well then, this is not necessarily relevant, like to be, or at least not coupled together.
So even this is considered like a commit. So you're saying I should have said something more vague, like we as we process messages from the queue, we need to um, update. We have to make updates in the database, and then I would start talking about, okay, this is how it look like in the database. Is that how I should have
No, what
went?
I'm saying is that it's not like a hard and fast rule. Stop. I want to say like stop being mechanical. Start thinking about the question that you need to ask yourself. Stop focusing on like this is the step I must exactly do in every single question. Don't think like that. Think about the questions
Okay.
and things that you need to consider, and be a little more flexible on that. That's what I mean. So in this case, let's say that we knew we need to process like messages from a queue. That's
Okay.
that's pretty straightforward given like Kafka's whole thing.
Hmm.
So
Hmm.
what we need to do is update the user like post. Yes, that is core to our thing. We definitely knew we need to at least address that.
Yeah.
The next question is, well, now that I've updated my liked posts, how do I actually handle the post counter themselves? That's a question I want to ask. So it's like, yes, in a sense, you committed yourself really early, but it's only because you didn't ask yourself that question of how do I want the post counters to be updated? Do I want them to be updated every single time I update a post? Do I want to offset that? And this is not necessarily the wrong answer. But the thing is that you need to ask yourself that question. If you ask that question and then say, hey, yeah, we can do this, and then you update later, I can live with that. But you committed yourself to it without asking that question. That's the difference.
Um, I Okay, I guess I just wasn't really seeing this as like a commit. Um, at this point, I was just more like I guess like what I was trying to say is like, okay, we once we process the messages from the queue, we have to update the user like post as well as the post counter. But does this actually like signify like commit? Like
The reason why it
I
signifies
guess
commit is
I'm not very
because it exists outside the scope of what you're doing. So, like I said, design an all real-time like counter solution, right? In a way, you
yeah
might think, oh yeah, well, we just need to update the post like counter, right?
yeah
And then we update the like post. But the thing is
yeah
that the post counter, it can be argued that it is dependent. The counter is dependent on the liked posts. Let me type that in.
okay
Post
okay
is dependent on the liked posts, right? So in theory, this should have told this should have suggested to me, one, your liked post exists in another database. Two, you are updating, like this is what the implications are. You are updating post counters so on its own. So which means that you've said two contradictory things. The first one is that the post counter depends on the liked post, because otherwise why would you have a separate database so that does not join? Or you're saying it is not dependent. Which is it? If you're updating on its own, why do you need? Is it really dependent?
okay.
Does that make sense?
Let's see. Yeah.
What's the dependency relationship on these two? And that you kind of, and the reason why it's weird, and this is like why it's weird, is because you've said simultaneously both at the same time. So you didn't make that relationship clear. Does that make sense?
Yeah.
Okay. So that's something that I would keep in mind. It's like it just make sure that every single component you understand the dependency relationships of them. So and then so that's why I decided, okay, well, and that's because it's because you did this. I said, hey, let's actually try defining what exactly the database looks like. And then we went through the whole exercise of, hey, we decided to put it as an edge, right? But then we realized, wait a minute, why do I need to do that? And like I said, you need to draw this story out. Like, why are we doing this? Why is this the best solution for what we need? And I really want you to focus on this question. Every single decision that you make, you need to ask yourself, why is this the best? I feel like you're still trying to throw out random shit and then fix it later. I want you to do the reverse thing. I want you to ask yourself, why is this the best? And then commit to it.
Okay, I actually have a question. So, because last week when we talked, you mentioned about like I want to be able to reiterate and like build on my idea, right?
Correct.
And so so that's why I initially started. That's why like it was like, I first talked about we have an edge edges to post, but then I was like, okay, but this may not be efficient, blah blah blah, and then I talk about, okay, what if
no,
we have,
I had to bring that up. You didn't
on...
acknowledge whether or not it's efficient. I had to ask you whether or not this is efficient.
Yes, but I didn't feel like I was like, I guess like, okay, I guess I did sound like committed enough to the point where you had to bring it up.
Yeah. To me,
Okay.
it sounded like you were saying, "Hey, this is a great idea. Let's run with it and move on."
But is it okay for me to like reach this point of like, edges to pose, and then 5 seconds later, I'm like, okay, wait a minute, do we actually need this? Blah blah blah, and then like start talking about how we could do this differently, or
Yeah. Okay, go ahead.
should I like, talk about it way more before we even get to here?
It's an art to it. I would say the best route is to vaguely suggest that this is a. I would say like my first idea is X, but we run into Y problem. I mean, because I'm trying to work with what you got. Like, I think most people would. I think that most people actually, if they're highly skilled, what they'll do is establish the parameters of the problem, and then suggest a solution that fits the parameters, and then acknowledge the shortcomings. That's basically what the ideal quote-unquote solution is. Because, like, what exactly, like, in this particular case, what exactly is the parameter of our problem? The parameters is that we need to have a way of efficiently expressing all the different likes that the user has been doing. Because this is going to feed into our like counter. So, that's the parameter. The question now is, well, what's the solution that fits that? Yes, technically, in theory, edges, just having the edges to post would work. But then what does that actually mean? That means that whenever we want to update the like counter, we need to pull this one entry out of this one user for every single post. So like we have like 10,000, like say 100 posts, right? Each time we have those posts, we have to query this user for all the edges to post and then filter that based on like likes, right? Or even worse, like, we have to query for every single user that has this post ID in this string field. And that could take a really long time.
Yeah.
So this is what I mean by, okay, this is a solution, but you need to acknowledge that this is like what's going to fuck it up. I didn't hear that.
Okay.
You need to be the one saying, okay, I suggested this, but this is like what I am going, this is like this is what's going to be wrong with it. I want you to get in that habit of like really vetting your own idea. You can suggest it, but then you need to also say why it's good or bad. Sometimes it could actually be good, But it's like the common trend I'm noticing is that this idea of trade-offs. You don't really do too much of that. I think you just like go with it, iterate when you see a problem, and then move on. And that's true. That is like the bare basics of what you need to do. But you need to more like be, how to say, cerebral about it. Be more deliberate about your decisions instead of saying, "Oh yeah, we ran into this problem. Let's update." That's basic. That's basic baby shit. We want to be able to anticipate those inefficiencies ahead of time. That's what's really going to get you that L4 offer.
All right.
Hard, right? Yeah, it's pretty fucking hard. Don't get me wrong. That's why system design is very, very hard. It's confusing, right?
Yeah. It's just like knowing like when, I guess like the timing of like, I guess timing is like what I need to work on. It's like even as I was like talking about the edges to pose, I had in my mind that okay, this is probably something that needs to change, but I guess like I just need to work on like being able to talk about that immediately and discuss about the trade-offs
right
sooner.
Mm-hmm.
Like that basically like as soon as I bring something up, I have to talk about it.
So
instead of like,
here's a simple exercise. When you bring up an idea, say why it is good, why it is bad. There you go. How about that?
Okay.
Is that gonna help you?
Yeah, I think it will.
Okay. Every other idea that you think is a little bit out of left field that you're not sure of, just say why it's good, why it's bad.
Okay.
Other than that, I think that's basically what I wanted to see. I want you to relax a lot more. I think that you are very paranoid. So let's do this. For this week, since you have Amazon, right?
Yeah.
And we said we want to schedule Google for like 2 weeks from now, right? And Facebook at the end of the year, right?
Google is 2 weeks from now. Facebook, I have yet to talk to the recruiter, but we started it. Google is gonna be in 2 weeks exactly. The 14th.
So this is the 14th, right?
Yeah.
So let's do Facebook. Would you be okay with pushing Facebook to the next year? Because I want to get some Uber results before we go to Facebook.
Yeah, personally, like I am okay. I would just need to talk to a recruiter and see what the timeline is gonna be like.
Yeah, just say that, hey, we're dealing with end of the year code freeze, perf. I'd like to go into New Year with a fresh mind and go into the interview with a fresh mind instead of like having all the shit weigh on me. I think that people will be okay with that.
Yeah, that, but also like initially I was also thinking of like having like Google and Facebook not too far apart from each other, because what if I get like the Google offer and like I might be tempted to take it.
Believe me, Google moves like a fucking snail, and you're going on the 14th, which means that you won't hear back until the end of January at earliest.
Really? That long? It takes them that long?
Yes. Google takes a very long time. They're notorious for doing this.
Okay.
So I want you. Is that even if Google offered you something, I would still say your Facebook will get back to you in a week or two.
Okay.
So we'll just schedule Facebook for early January. Uber is very fast as well. So I would not mind if you did Uber the week after.
Okay.
So week after G, then Facebook early January, because then we should be able to get Uber and Google signals by then. But this week I want you to, so let me write down Amazon 11:30. So I want you to take this week to really relax. I want you to really focus on the flow of a problem rather than the mechanics of it. And just be able to make sure that you can say why things are good and bad in system design. Don't worry too much about system design right now. I think right now we want to try and make sure that you do pretty well on the data structure and algorithm. But this idea of trade-offs is not exclusive to system design. It also applies to data structures and algorithms as well. That every single decision that you make for for doing a portion of the problem or whatever design that you decide, like whether that's a frequency map, whether that's say two-pointer, you need to be able to say why it's good or why it's bad or why it's optimal. And any like if I stopped you and said, hey, why did you do this, and you could tell me why it's good or bad, it doesn't change. I'm just making this idea more visible to you.
Okay.
All right. So that's going to be it for me. I think that, like I said, just slow down, chill, to spend this week chilling. Try to do a few problems without going to the practice diary. I'm going to say don't do the practice diary this week. Just do problems and let the idea flow to you.
Okay. And you said I should try to schedule Facebook early, like first week of Jan?
If you can, talk to them about it, see what they're willing to do for you.
Okay. Would you be okay if it was like last week of December, like 27, 28?
They will not do that because everyone is on vacation.
Okay. Okay. Then
I would not mind if you got that, but I don't think it's likely to happen.
Okay, for sure.
All right. Is there anything else?
No, nothing else.
All right, for sure, man. Then I'll check in with you on Thursday.
Right.
For interview, we can skip that if you want because I'm trying to ask you to take it easy.
Okay. Yeah, let's just check in on Saturday then. Unless if I need something to replay, I could ping you. But I think we can skip it.
Or we can talk about your Amazon interview as just like a chill thing, like, hey, I did this XYZ. What do you think I should have done here?
Yeah, I think that would work as well.
Okay, yeah. So if you have if you can prepare for Amazon and just take some notes of what problems you did and what you may or may not have done well, I think that'll be fine. And we can chat about that Thursday.
Okay. All right, sounds good. All right, thanks, man.
Yeah, for sure. Don't spend tonight, relax, clear your mind, get a good night's sleep, and good luck tomorrow.
All right, thanks, man. Talk to you later.
All right, talk to you later.
Bye.
All right, so I guess that's gonna be it for him. Any questions from the stream? I see we have a few messages. First one, the system design part is most tricky and fun at the same time. Yeah, because essentially what you're doing, and I've mentioned this in the intro video, is that it's a game of trade-offs. And how you choose to navigate that is going to be based on your experiences. And in general, the more experienced you are, the better and more efficient you'll be at making those trade-offs. You'll make faster and better trade-offs, and you'll understand a much deeper depth of detail for that. So that's really all this is. Like the whole exercise of like explaining why an idea is good or bad is that anyone at like L5, L6 level, I could stop them and ask them why it's the best or like why they made this decision. A bad engineer at like the L3, L4 level is going to say, I don't know, it was just an idea. L4 plus L5, L6 are going to be able to say exactly why they chose this and be able to dive into that line of thinking. It's hard if you haven't worked on something similar. Yeah, no. I would say half true. The reason why is because if you've worked, and I mentioned this in the system design intro video, is that if you worked on a system, you may not have created it from the ground up, but you're familiar with the shortcomings of bad decisions of that. So what I mean by that is that if you design a product incorrectly, or you have chosen the wrong sharding mechanism or done something wrong like that, you basically get blown up pretty hard. And you might not know the right way to do things, but you could say 1,000 wrong ways of doing things, and you could tell me what the trade-off is on those, the mistakes. And from there, you could say which is the idea that sucks the least. No matter how you cut it, as long as you've actually tried to do something, a microcosm of a product at that scale, you should be okay. I think that's the way I see things. And yeah, with practice and practical experience, you'll get better at this. Anyway, so if there are no other questions, we'll stop the stream for today. We will have a stream tomorrow. Fortunately, there is a client that will show up at 9 p.m. So we'll have a stream 9 p.m. tomorrow. And then we will have our talk about his Amazon interview on Thursday as well. So at 8 p.m. Pacific Standard Time. So thanks you guys for watching. Follow me on Twitter. Join the Discord. Hopefully you guys are, and thank you all for watching. Hopefully you guys are ready for your upcoming interviews. We have all the past sessions available on YouTube for you to watch. So with that, have a good night, and hopefully I'll see y'all tomorrow.